All right. This is day 46. We are back at it again with another set of lead code questions. Let's get it. Actually, okay. Okay. There are a total of num courses you have to take labeled from 0 to num courses minus 1. You are given an array prerequisites where prerequisites of I equals AI. BI indicates that you must take course AI first if you want to take course BI. For example, the pair 0 1 indicates that you have to take course 0 before you can take course 1. Prerequisites can also be interactive. Course A is a prerequisite of course B, and course B is a prerequisite of course C. Then course A is a prerequisite of course C. You are also given an array queries where queries of I, uj, vj. For the jth query, you should answer whether course uj is a prerequisite of course vj or not. Return a boolean array answer where answer of j is the answer to the jth query. Interesting. Okay, so we basically need, this seems a pretty easy question. We just need like BFS kind of shit, right? Or like a topological sort. So okay. Let's take this example. Copy. Now here we have three courses, namely 0, 1 and 2. Zero, 1, 2. Now 1 is a prerequisite for 2. So we make an arrow from here to here. 1 is a prerequisite for 0. And 2 is a prerequisite for 0. Right. So these are the things. So we calculate in degree for each node. In degree means how many arrows fall into that node. So for 1 it is, for 0 it is 2. Let's note that here. This is in degree. In degree. For 0 it is 2. For 1 it is 0. For 2 it is 1. Right. Now we pick the nodes which have 0 in degree in our queue or whatever list, let's say. Then we remove 1 from each branch or whatever. We remove 1. How does that work? Let's see. So 1 basically has no prerequisites. I can store that here, right? Then we check what are the neighbors of 1, right? Neighbors of 1 are 0 and 2, right? So in the queue we have 0 and 2. Okay. Can I just store? Am I making this too complicated? Instead of doing all of this, why can't I just store? Let's say for 0th node, I'll store how many arrows are falling, like which nodes have, like, yeah, basically for 2 I'll store 1 in the set. For 0 I'll store 1 and 2. For 2 I'll store 1. For 1 it is an empty, so nothing will be there. And simply I just check the queries here. What is the query? If uj is a prerequisite of course vj. Now I check if 1 is there in 0th subset. It is there, then this is true. If 1 is there in 2 subset, this is also true. So both are true, right? Yeah, it's a simple hash set kind of thing, right? But this won't cover transitive things. But I can go. Okay. But that's kind of DFS. But yeah, I need. Okay. Queries is 10 to the power of 4. Num courses is 100. Prerequisites is also in the same kind of okay. Okay, interesting. I mean, yeah, BFS or DFS is possible here, but that will be time limit. I mean, TLE for sure. What are the topics? DFS, topological sort. What is the advantage of doing topological sort here? So topological sort, 1 has 0 in degree, right? Yeah, in topological sort, since this is only 100, I can check if that subject comes before this subject. If that is the case, then it is true, otherwise it is false. So topological sort might work here. And since this is only 100, so it will kind of constant time. So yeah, let's do topological sort. For topological sort, we need to create a graph first, right? There, so let's create a graph. A graph would be list of list now num courses, right? Yeah. Now for every prerequisite, graph dot get p of so 1 is a prerequisite of 0, right? So p of 0 dot add I can do this. What am I doing, bro? Graph dot put p0 array list, then graph dot get p0 dot add p1. This will be my graph, right? Now should this be put in a queue? Yeah, I think so. For list of integer node in graph, if node okay, if graph dot get I dot size or is empty, then q dot add I, right? Bro, I actually forgot topological sort, so let's see that what happened there. DSA, not dynamic, brother. Trees and graphs. Yeah, topological sort. Only for directed acyclic or acyclic graphs, it is a linear ordering of vertices such that for every vertex u comes before v in the ordering. Yep. Yep. Let's see the code. So what are we doing here exactly? Count the number of inbound edges to every vertex. Okay, for every vertex we increase the inbound count, push the nodes to the queue whose inbound count is 0. Now, what is this indentation, brother? Okay, we store inbound count in a separate array. Push the nodes which have inbound count as 0. Process. Okay, makes sense. Then where are we pushing the final thing? Yeah, result, right? Where are we pushing that? Result or pushback current? Okay. Makes sense now. Okay. Now we have a graph, right? Yeah, adjacency list. Okay. We can also store inbound count here also. So int inbound or in degree new int num courses in degree of p1 plus plus. For every neighbor in that, right? We decrease the in degree by 1, right? So in degree of neighbor minus minus, if in degree of neighbor becomes 0, then process next dot add neighbor, right? This was the code, right? Yeah. Yep. And then we add this to result or topo sort. Okay, now this topological sort is done. Now we just need to process each query and just see if that subject comes before the second subject. Then for int q in queries, right? We just need to see if q0 comes before q1, right? Get index of element in list Java. Dot index of. -1 if the items is not found. Int L equals Q dot topo sort dot index of Q0. Int R equals topo sort dot index of Q1 if L is not equals -1 and R is not equals -1. If L is less than R, then list of boolean, right? Let's also make that list of boolean result equals new array list result dot add true, else result dot add false. Let's see if I have cooked here. The fuck? Bro, I'm so cooked here. Damn, bro. I need to do this, bro. Instead of doing this, let's do this. All right. Then we don't need to do this. Okay, false. Okay, now. Okay. Yeah, now this is a tricky one. after topological sort, what can we do? Like, should I just add a check if prerequisites is empty, then just return false? Like, if dot is the fuck? Damn, bro. What? I don't think this will work, man. Yeah, okay. Let's look at the solution, how they have used topological sort, Floyd Warshall, and cube. Okay, let's see this. C is prerequisite of B. So when we do a topology search, just simply add A's direct prerequisite B to A and also prerequisites of B to A. Besides this part, everything is same as course schedule 1 and course. Okay. So what happened here? So we have in degree, we have an adjacency list, we have a prerequisite map. For I in this prerequisite map dot put a new hash set and an adjacency list. Then for each prerequisite in degrees increase, adjacency list is populated. Then for Q, if it is this, got it. While Q is not empty, set we get all the neighbors, then we traverse all the neighbors. Then prerequisite dot get next dot add this dot get next dot add node, correct. Dot get add all prerequisite dot get. Oh, in degree degrees. Okay, yeah, this is way easier to understand. So this guy took prerequisite map here. Interesting, very interesting. And he's using a set because to speed up the process. Then we don't need this bullshit. And let's also use hash set because this is way easier, man. Hash set is way easier. hash map, sorry. Map, hash map. Okay. So we need a map from integer to a hash set of integer, right? Just a set. Graph equals new hash map. Prerequisite map. Okay. Prereq map dot get neighbor dot add current, right? And also add all of the elements from prerequisites of current, right? Add all. Okay, this guy is good, man. This guy is good at Java. Okay, if in degree is 0, then we add this. Then we don't need this. Then for each result, for each query, we simply check if prereq map dot get q, if this is a prerequisite of that. So q of 1 dot contains, or is it find? Contains. If this contains q of 0, then result dot add true, else result dot add false. Easy. Yeah, this was way easier to understand. All right, so this was the question for today. I'll be back tomorrow with another question. Until then, GG's.